Siri, what's the name of the guy I had a meeting with a couple of months ago at Cafe Grenel?
In this video, I'm going to explain why the problem is incredibly difficult. And more importantly, I'm going to show you the architecture needed to solve it. Because for the last 2 years, I've been building systems designed specifically to solve this very problem. This sentence sounds simple, but look closer. This isn't just a language problem. It's a lookup problem. The AI has to first understand the user's intent and identify which entity the user is actually referring to. Who is the guy? A contact? Someone from an email? A calendar invite? A person mentioned in messages? The system has to decide where to even begin searching. Then it has to scope the query correctly, out of potentially years of meetings, conversations, locations, and interactions. Which one is the user actually talking about? This is where constraints become important. A couple of months ago, Cafe Grenel, these aren't just words. They're filters, signals, constraints the system can use to narrow the search space. But the hard part is knowing how to resolve these constraints. Time is vague. Locations may be incomplete. The cafe might not even appear directly in the meeting data. The AI has to reason across multiple systems and connect fragmented information together. And this is the key most people miss. Solving this reliably isn't just about having a smarter model. It's about architecture. Because this isn't just a Siri problem. This is a foundation of every real-world AI system. No matter the industry, they're all sharing the same underlying challenge. Every domain has data, schemas, entities, relationships, constraints, and systems of record. And the AI doesn't need to generate language about these things. It needs to understand how the world behind them actually works. What entities exist? How are they connected? Which systems are authoritative? What constraints are valid? What information is missing? And what actions are safe to execute? The reality is intelligence becomes dramatically harder the moment it interacts with structured reality. Because the real world is not just text. It's interconnected systems. And if we want AI that operates reliably in healthcare, finance, legal systems, or even something as finding a movie, then AI needs to understand the world underneath the interface. Now before we continue, there's something you need to know about the demo you just watched. What you just saw was not fake UI animation. It was real reconstruction of the orchestration process the engine performed to arrive at the solution. Every step, every decision, every lookup, every constraint, the reconstruction was generated directly from the engine's execution flow, but in slow motion. To build a system like this, I needed a domain with structured real-world data that was publicly accessible, so I chose movies. Movies turned out to be the perfect problem space, because underneath the interface, it has all the same characteristics as a real-world enterprise system. Top 10 movies on Netflix from 2025. Even a query this simple requires the system to understand intent, resolve constraints, resolve missing intent, search authoritative systems, verify streaming availability, rank results, and construct an answer in grounded reality. Inside the Tama Engine is something I call the Fractal context engine. Instead of treating the language model as the intelligence itself, the system treats the model as one component inside a larger orchestration architecture. The Fractal context breaks the problem down into smaller steps, evaluates the available context, determines what information is missing, decides what the system should do next, and therefore decides which context should be dynamically loaded. In other words, the intelligence layer moves outside the model and into the abstraction the developer can actually control. Once the intelligence layer moves outside the model, the system gains advantages that traditional AI's architectures simply don't have. You no longer need a giant model trying to solve an entire problem by itself, because the orchestration layer handles reasoning, constraints, context management, and execution flow. Smaller models become dramatically more effective, which means lower costs, higher throughput, and significantly lower latency. Instead of brute forcing intelligence, the system becomes deliberate about where intelligence is applied. The architecture becomes observable. Traditional AI systems are often black boxes. Something goes wrong and nobody knows why. But in the Tama engine, each node has a clear responsibility. Each decision is isolated. Each step is traceable. So when a failure happens, you can pinpoint exactly where the problem occurred inside the orchestration network, which means the developers can debug and improve the system systematically instead of guessing. And this leads to the biggest advantage of all. Developers no longer have to treat AI systems like mysterious black boxes. They can iterate on them, the same way they iterate on deterministic software. Problems become reproducible, behaviors become understandable, improvements become measurable. The system evolves through engineering, not superstition. And that's the fundamental idea behind the Tama engine. Intelligence isn't something you blindly prompt into existence. It's something you deliberately engineer. Developers program the Tama engine using a declarative approach. The intelligence network is defined through a simple duality. HCL defines a structure, Markdown defines a behavior. Everything becomes structured data. And that fundamentally changes the where and the how of intelligence. Developers aren't rewriting runtime behavior, they're evolving the network. And because the system is declarative, iterations no longer take weeks, it takes seconds. The network becomes a single source of truth, one place to build, one place to version. And this is where the distribution becomes incredibly powerful. Because once orchestration becomes declarative, the intelligence layer itself becomes portable. The entire network can be distributed across runtimes, devices, and edge environments as lightweight structured data. This is the holy grail of local and on-device AI. When developers ship updates, they aren't shipping an entirely new application stack. They aren't forcing a massive download. They're updating the intelligence layer itself. Lightweight data, heavyweight intelligence. And that separation changes everything. For the first time, we can improve the mind without rebuilding the world around it.
How do I,
Ask it.
ask it?
Lucas would like information on secret codes and ciphers. Lucky you. Several of those are actual books.
Find me some movies that make me excited about the future. Something recent. I'm excited to announce that Memovee is the first real-world application powered by the Tama engine. The public beta is available today on iPhone, Apple TV, and the web. This isn't a concept. This is the future of intelligent software. Welcome to the future.